ನಮಸ್ಕಾರ ವೆಲ್ಕಮ್ ಟು ಟೆಕ್ ಗರ್ಲ್ ಕನ್ನಡ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್.
Create a heap in a top-down approach. This is created by successive insertion of the new key into the previously created heap. The new item say key should be inserted always after the last leaf in the existing heap. Procedure obtain the item to be inserted and its position. This position is called child's position. As long as parent exists and item is greater than parent, you can move the parent down to the child and make parent as the child. Obtain the position of the new parent. Insert the item into the child position. Algorithm top down heap n comma a. That is how it is constructed. Prefer to sort the item by using heap. This is done by top down of heap, that is for I n minus 1 down to 0. Exchange a of 0 a of I. Bottom up heap I comma a, repeatedly exchanging it in this manner. Construct a heap for the list 50, 25, 30, 75, 100, 45, 80 by successive insertion using top-down approach. By successive insertion, but here they have given the final answer for the heap. 100, then 75, 80, then 25, 50, then we have 30 and 45. How it is obtained? By first we have to take the larger number as a root, and then we have to take the less than that number, which is left hand side of 75. This 75 is in left hand side of the 100, so that we will take, and then 80 is right hand side of the 100. Then after that 50 is, firstly this 25 is there, and 50, 25, 30, 50 are there. Since everything are there in the left hand side of this 75, we will consider the smallest one, that is 25, and instead of taking 30 we are taking 50 first, because that is the first element we got. Then we have taken 30, which should be in the left side, and then 45. This heap sort is f1 of n plus f2 of n. Create heap, do it to swap, then recreate heap. Time efficiency 2 power n h minus 1, that is log n to the base 2, theta of log n to the base 2. Then space and time trade-offs. Introduction. Sorting by counting. Input enhancement and string matching. To design an algorithm, consider both time and space factors. To achieve time efficiency, is it possible to leave the space issues? Or to achieve space efficiency, is it possible to leave the speed of execution, or there should be compromise between space and time? This is called space and time trade-offs. This is an issue while computing space and time trade-offs is a situation in which either time efficiency can be achieved at the cost of extra memory usage, or space efficiency can be achieved at the cost of execution speed. There should be compromise between time and space based on the situation. Time factor is preferred over space. Why? Because these are all methods of achieving time efficiency are there. Input enhancement, sorting by counting, horse pools are there. Pre-structuring, hashing are there. Input enhancement. Given a problem and various inputs, the inputs is pre-processed to get additional information about the problem. The additional information thus obtained may be stored in the form of a table, which may be used by an algorithm to get the required result with less time. Sorting by counting. Comparison counting sort, distribution counting sort, or linear sort. Pattern matching, Horspool's algorithm. Pre-structuring uses extra piece to facilitate the faster and flexible accessing of data. Same processing is done before a problem. It deals with accessing the data. DP, dynamic programming, method of solving a problem by recording the solutions of the overlapped subproblems of the given problem, a table, and use these recorded solutions to get the solution for the given problem. When a subproblem by earlier instances encountered, instead of recalculating it, the values, it simply retrieves from the table. Then computing the binomial coefficient is like this. Finding the transitive closure using partial solve pairs of shortest path problem using floats. Sorting by counting. Methods of arranging numbers in ascending order is called counting. Sorting by comparison, sorting by distribution. Then comparison counting. For each element A of I in the given list, find the total number of elements E of I that are less than A of I. Count C of I obtained in previous step will be the position of A of I in the final sorted list. That is E 25, 45 and all. Here the comparison counting gives the number of elements less than each item. We will take 25. And is there any number which is less than 25? Yes, that is 10. Count of this 25 will increase by one number. Then that will become added to this. That will be increased this. Positioning is given by this numbers. So at the end we will have 0 to 4 and j is I plus 1 to 5. Index variable I varies very frequently. This I is 0 to n minus 2 and I plus 1 to n minus 1 gives A of I less than A of j is C of j is C of j plus 1. L C of I is C of I plus 1. And if and n for. Insert A of I into the position C of I in the array B. That is B C of I is E of I for I equals to 0 to 5. Algorithm comparison count as given above in the same way we are having here. Tracing is nothing but we are having the count areas like this, where we will find the count of each item, then 3 for 10. So which means the 10 should be there in the third position, like that. The first element should be there in the third position. That will be 25 is at third position now. Then time complexity in the best case and worst case remain same. So parameter is considered as n, and for this is theta of n square. Sigma of I 0 to n minus 2, n minus 1 and plus n minus 2 till 1, descending to n minus 1 by 2, n square by 2 minus n by 2, which is equal to theta of n square. Disadvantages: uses more space. Other than that, then algorithm work correctly for arrays with equal values as well. Because we will use the criteria as it is less than. Then for the input enhancement in string matching, given a string called text with n characters and another string called pattern with m characters, where m is less than or equal to n, it is required to search for the string pattern in the string text. For this, in input enhancement technique, we have Knuth-Morris-Pratt algorithm, Boer-More algorithm, Horspool's algorithm. Horspool's algorithm in which we use the shift table for comparing the elements. Align the pattern string against the beginning of the text string. As long as there is no match or end of text string, perform the following steps. Start comparing from last character of pattern string with substring of the text string. Match, return the position of the pattern string in text string. Take the last character of substring of text string that is being matched with the pattern string, which becomes an index into table S. Using this index, obtain the value from the shift table. This value given the number of shifts required. Let us compute the shift table first. For the pattern string of length m barber, we have there is a length of 6. Then for bar we have to give indexes for all the alphabets and numbers as the length of the pattern, but only for these. For E R we have to leave as it is, since the distance is at first from the right. We have to give the index for E as 1, B as 2, R as 3, and A as 4, and B as same value as the right hand already. Then it is arranged in this manner. Then the shift table, which gives the number of shifts we have, we will get this from the end. So P of I is at a distance of 5 minus I, m minus 1 minus I. M minus 1 minus I. Pattern of I is in the position of m minus 1 minus ith position. So then algorithm of shift table is here. And then shift table of P comma S is written like this. We know about Shastri. The pattern which we have to find is about. For about, we have this shift table as 1, 2, 3, 4. And then we will be finding it. In this way, we have to find. That is, for example, for I 0 to 127, we will be adding the shift table. And we also made this for I 0 to 3 do S of P of 0 equals to S minus 1 minus 0. That is M minus 1 minus I. Right, M minus 1 minus I. M is 5 because the pattern string length is 5. That's why we have taken 5. This is the tracing of the shift table. And then analysis of this parameter to be considered are m and n. Basic operation is T of I minus k equals to A of m minus 1 minus k. It gives you mn, or big O of mn worst case. But in this pattern string is found at the beginning number, so that it will be omega of m. Iterations only will be taken, omega of m.
Thank you for watching. Do like, share, and subscribe to my channel.